determines a function. A function is when every value from the domain, or the x values, are paired with exactly one value from the range, a different value from the range, which are the y values. So if I were to look at the data set that's written in black, I see my domain over here, 0, 1, 2, 3, 4. And I don't see any repeats of any values. So that's a good thing when we're determining if something is a function or not. Now in my domain I have a 0. 0 is paired only with a 1, and it's not paired with any other value from the range. So that's good. The 1 is paired with 2. 1 is not in here any other place, so it can't be paired with a different y value. So that's good. Same thing with 2. 2 is paired with 3, and the 2 from the domain is not paired with any other value from the range. And as the same is true for 3 and 4. So this right here would be a function. If I were asked to determine what the slope of this is, well, I see that my values, my domain values change by 1. So that's my run. They increase by 1. And I notice that my range values increase by 1. I can just tell that over here, just by looking at it, it's an easy set of data points. I'm going up by 1 each time. So my change in my y values is a positive 1. My slope would also be 1. Sometimes you may be asked to determine both. So yes, it is a function, and the slope is 1. Now looking at the blue set of data points, I see in my domain something a little strange. I've got domain values that are repeating. Now that does not mean for certain that I don't have a function here. What I have to do is look at what y values those domains are paired with. So for example, 0 is paired with 1. That's okay. But then I have another 0 that's paired with a different value. It's paired with a 2. So automatically I can tell that this is not a function. Not every domain value is paired with a different y value. 0 is paired with a 1 and 0 is paired with a 2. 1 is paired with 3 and 1 is also paired with 4. So there are several instances in here that's stopping that data set from being considered a function. In order for something to be a function, every x should be paired with only one y. So now I'm looking at my purple set of data points. I've got different domain values. In case you forget, this is the domain. It's the x's. This is the range. I mentioned that in the last video, but it doesn't hurt to mention it again. Each domain value is different, unlike the blue set of data points. So when I look at these data points, I see that 0 is paired with 1. There's no other 0 paired with a different number, so that's okay. 1 is paired with 1. There's not another 1 that's paired with a different number, so that's okay. 2 is paired with a 1. There's not another 2 in the domain, so that's good. And 3 is also paired with 1. There's not another 3 in the domain, so that's fine. Some of you might be saying, yeah, but what about the range? The 1 shows up several times and it's paired with a different data point each time. The range does not matter if it repeats. It's the domain that matters. So because my domain values are only listed once, and they're not domain values that are paired with 2 or more range values, it meets the criteria for a function. So the purple, yes, it's a function. And if I had to find the slope of this, I would see that for the slope, the run is 1, it increases by 1. The y values don't increase at all, they stay the same. So 0 over 1 means the slope is 0. Okay, now what I did over here, even though I couldn't put a piece of graph paper on this, I tried to graph these as best as I could. The black graph represents the black set of data points. So I have a line that's increasing from right to left. You can see it's linear. It's as straight as I could get it. Drawing with this pen and tablet's not always easy. And sometimes you can test if something is a function just by having its graph. I'm going to try to use a different color here, and hopefully this doesn't get too messy having 3 graphs on one coordinate plane. In order to test a graph to see if it's function, we do what's called the vertical line test. We can take the graph And as long as we can draw a vertical line and cross the graph at only one point at a time, we're okay. Now remember, I have 3 different graphs on here, and right now we're only looking at the black graph. Let's see, some of you might not see greens very well, so I'm going to change to this light purple color, and hopefully it shows up okay. So if I were to draw a light purple line anywhere along this black line, since it's a function, we already determined that the black set of data points made a function. No matter where I draw these purple lines, these light purple lines, I should only cross the black graph one time. And I do, no matter where I draw that. We already knew it was a function, so I knew in the back of my mind that that should happen. Okay, let's look at the blue set of data points. We determined already that that one was not a function. That data set is not a function. If all I had was the graph and I didn't have the ordered pairs in the table like I do, I could look at the graph and say, if I draw one of my light purple lines here, it crosses 2 blue dots on the same vertical line, even though it's not a very straight vertical line. Same thing is true for this set of blue dots. If I draw a vertical line, not bad. I cross the blue points 2 times in one vertical line. That also can determine for me that, no, this is not a function. That shouldn't happen. It fails the vertical line test. So that helps me also reinforce that the blue set of data is not a function. Now back to the purple set of data. I drew the purple line for that. We determined that the purple set of data would be a function, and so I graphed it. You can see it's linear also. Its graph makes a straight line. When I draw my vertical lines anywhere along the dark purple graph, I only cross, no matter where I draw it, I only cross that dark purple graph one time. So that darker purple graph would pass the vertical line test, which also helps reinforce that, yes, this is a function. So there's 2 ways to determine if a set of data points is a function or not, depending upon how you're given the data. If you're given a table, like I started with, you want to make sure that every data point in the domain is paired with only one data point from the range, not 2 different numbers. If you're given a graph, you want to use what's called a vertical line test. As long as a vertical line anywhere on the graph only crosses it once, then you know you have a function.